Well, hello and welcome back to math class. Today we are going to look at the distributive property and then the answer we get from that. So for example, we did some arrows and we know that that arrow means multiply. 4 times n is 4n. We keep our plus. Then we distributed and we said 4 times 5 is 20. And so this was the final answer that we got after we distributed. What we're going to do today is we're going to actually take the answers and we're going to see if we can work backwards to get the distributive property. Okay, so that's what we're going to work on today. We're going to look at answers and we're going to make the distributive property. So today's lesson is on lesson 5.5 and it's called factoring expressions. And so if you were listening, I said we're going to kind of use the distributive property and we're going to factor it. So we're going to take the answer and we're going to use and turn it back into the distributive property. So we'll factor our expression. Let me show you what I mean. Let's look here at example number 1. Factoring numerical expressions. Well, this is an expression, right? And it's 18 plus 30. We're going to factor it. So I'm going to look at 18 and 30, and I have to think of a factor, the greatest common factor that they both have. Well, if you don't know your factors and your teacher's giving you a factor sheet, you're going to look at 18 and 30. So here's one kind of a factor sheet that I have. Here is 18 and here is 30, and I have to look at the factors they have in common. They both have a 1, they both have a 2, they both have a 3, oh, they both have a 6. Looks like 6 is the largest factor that they have. So I look at 18 and 30. I know that the largest factor they have is a 6. So I pull out the 6. Now I'm going to make the distributive property. There's a plus. I'm going to keep a plus. I have to think about 6 times what is 18? Well, this would be 6 times 3. Now I have to look at the 6 and decide what I would take it times to get 30. 6 times what is 30? 6 times 5. So what I've done here is I've taken my expression and I factored it. I pulled out a 6. Let's just check to see if this is right. Well, if I would take my arrows and I would do 6 times 3, that's 18. And then if I would do 6 times 5, that's 30. So I factored that expression. Let's look at this one here for B, factor 20 and 12. So we're going to pull up my factor sheet. I have to think of a factor for 20 and 12. Here's 12 and here's 20. Let's see, they both have a 1. They both have a 2. Oh, looks like they both have a 4. I don't see anything bigger, so the greatest common factor is 4. So I'm going to pull out the 4, make my distributive property parentheses, keep the sign, which is a minus. 4 times what is 20? My answer would be 4 times 5. Now we have to do for the second number. 4 times what is 12? My answer would be 4 times 3. Now let's double check it. I'm going to do my arrows on the bottom here. 4 times 5, 20, yes. And 4 times 3, 12, yes. So I was able to factor my expression. All right, we're going to do a little bit more practice here on these next 3 problems. We're going to look at 9 and 15. 9 and 15. Think of a factor, the largest factor that 9 and 15 have. If you don't know and you have a factor sheet, you can look at it. Here's the factors for 9, 1, 9, 3, and 3. Factors for 15 are 1, 15, 3, and 5. Looks like the largest factor they both had was a 3. So we'll pull out the 3. We'll make our parentheses. We'll keep the plus sign. We'll look at the first number. 3 times what is 9? 3 times 3. Now we have to look at the second number. 3 times what is 15? 3 times 5 is 15. So we have factored this expression. Oh, bigger numbers, 60 and 45. 60 and 45. I'm going to go ahead and make my parentheses. Let's look at 60 and 45. Okay. 60. Wow, there's a lot of factors for 60. Here's 45. Let's see what they have in common. They both have 1, 3, 5, 15. There's the largest. So we want to always pick the largest. Even though they both have a 5 and they both have a 3, we always want the greatest. And it looks like the greatest is 15. So we're going to pull out a 15. 15 times what is 60? Well, got to know my multiplication facts. 15 times 4 is 60. 15 times what is 45? That would be 15 times 3. All right, let's see if we can do this last one. I think I can do this last one without my factor sheet. All right, these are both 30 and 20. I think the largest factor that goes into both of those is a 10. I'm going to make my distributive property parentheses and keep my sign. 10 times what is 30? 10 times 3. And 10 times what is 20? 10 times 2. Now make sure, if you notice, I always made sure the first number went with the first number here in my parentheses. You cannot flip these two around because then your expression would be incorrect. All right, well, we're going to continue doing the same thing, but this time instead of just doing numerical expressions, we're going to do algebraic expressions, which means we're going to add a variable. We've added a 3. So our expression here says 3x plus 42. Well, I look at them and see what would they have, what's the biggest factor they have in common. Well, this has an x, this doesn't. So we're going to look at the numbers, 3 and 42. So I go to my factor sheet, I look at 3, I look at 42, and it looks like the largest factor they both have is a 3. So I'm going to pull my 3 out. I'm going to put my distributive property parentheses, my plus. Let's look at the first thing. 3 times what is going to give me 3x? Well, 3 times x. 3 times x will give me 3x. 3 times what is going to give me 42? Well, the answer is 3 times 14 is 42. So I'm doing the same thing as I did up here, but this time I added a variable. Let's look up our sample B. 63z minus 27y. Okay, well, we have two different variables, so that means we're going to look at the numbers, 63 and 27. So I'm going to look at 63 and 27. Let's see, I've got a different factor sheet. Let's look at this one. This one might help. 63, I've got 1, 63, 321, 7, and 9. And then the other one I had to look at was 27, 1, and a 27, a 3, and a 9. It looks like to me the largest number we have in common is 9. So we're going to pull out the 9. We're going to make our parentheses. We're going to put the minus. 9 times what is 63z? 9 times 7 is 63, but I need the z, so I can't forget the z. 9 times 7 would be 63z. 9 times what would give me 27y? Well, let's see. 9 times 3 is 27, but I need the y because I need 9 times 3 to equal 27y. All right. We've got 3 more problems to look at. Same kind of thing here. I would actually like for you to pause your video if you feel comfortable doing that, and I'd like for you to go ahead and solve these problems. So please pause your video and see if you can do this on your own. All right, so for those of you that paused it, and hopefully you finished, we're going to look to see how you did. We have 7x and 49. If I looked on my factor sheet, those both have a 7 and plus. 7 times what is 7x? 7 times x is 7x. 7 times what is 49? 7 times 7. All right, problem number 5. If I looked on my factor sheet, I have an 8y and a 44. The factor you should have found was a 4. Put my parentheses. 4 times what is 8y? Well, let's see. 4 times 2 is 8, but you can't forget the y. And 4 times what is 44? 4 times 11. All right, last one. 25a plus 10b, you should have found that you have a factor of 5 that you could have pulled out. My plus. 5 times 5 is 25 with my a. And 5 times what is 10? 5 times 2, but I can't forget the b. All right, so we're going to go ahead and practice a couple story problems with this now. Turn over to the back side. All right, here we have a story problem that says, let's get ourselves a little, modeling real life. You receive a discount on each book you buy for your electronic reader. The original price of each book is X dollars. You buy 5 books for a total of 5X minus $15. Factor the expression. What can you conclude about the discount? Well, it's kind of nice. They already gave us the expression. So we have the expression here, 5x minus 15. And it asks me to factor it. Okay, well, we just practiced that on the front side. We look at 5x and 15, and we have to find what factor do they have in common. Well, if I look at 5 and 15, the largest factor they have is a 5. So we're going to pull it out, spread my parentheses nice and far, leave a minus. 5 times what is 5x? 5 times x. And 5 times what is 15? 5 times 3. So I factored my expression. And then it says, what can you conclude about the discount? Well, if we look at the sentence here, it says the original price of each book is X dollars. X dollars meaning this is one book. Up here we had 5 books. So what did we conclude? We concluded that if you buy one book, you get a discount of $3. So we're going to conclude that you get a $3 discount for every book you buy. All right, if you need to pause this so that you can catch up, you can do that and then restart it when you're ready. All right, let's do the next one. It says, try it. A youth club receives a discount on each pizza purchased for a party. The original price of each pizza is X dollars. The club leader purchases 8 pizzas for a total of 8X minus $32. Factor the expression. What can you conclude? This is a lot like the one we just did. So we know that each pizza costs X dollars. Well, we bought 8 pizzas, so that's 8X. So we're going to write 8X minus 32. We have to factor that. All right, so if I look at 8 and 32, what do they both have in common? Yeah, their greatest common factor would be an 8. We'll pull the 8 out, separate my parentheses nice and far, put my minus. 8 times what is 8x? 8 times x. And 8 times what is 32? 8 times 4. So my factored expression is 8 times the quantity of x minus 4. What can you conclude about the discount? All right, so if x is one pizza and I get minus 4, that means I'm going to get a $4 discount for every pizza I buy. This time we get a $4 discount. All right, like I said, if you need to pause it so you can write this down, please do, and then you can restart it. All right, let's look at our last problem. 3 crates of food are packed on a shuttle departing for the moon. Each crate weighs X pounds. On the moon, the combined weight of the crates is 3X minus 81 pounds. What can you conclude about the weight of each crate on the moon? All right, well, let's go ahead and write our expression. And let's see if we can factor it. What do they have in common? Well, let me see. I'm going to pull out my factor sheet and look at 3 and 81. Well, I know 3 is prime, so the only thing that 3 has is 1 and 3. Let's look here at 81. 81 has 1, 81, 3, 27, 9, and 9. Oh, it has a 3. All right, so it looks like we're going to pull out a 3 here. Let's pull out a 3. Separate my parentheses nice and far. Put a minus 3 times what is 3x? 3 times x. And 3 times what is 81? Well, we just looked at our factor sheet and found out it was 27. All right, now it says, what can we conclude about the weight of each crate? Well, if you notice, each crate weighs X pounds, so X, we have a minus 27. So because we're talking weight, we're going to say that each crate weighs 27 pounds less on the moon than it does the Earth. Each crate weighs 27 pounds less on the moon than on Earth. All right, once you are finished writing this, you can go ahead and turn your video off. If you need to pause this so you can write it down, you may do that. Have a great day.